Hey guys, it's Thyworm here, and today I wanted to make a video about the last Epoch post, the 1.0 launch retrospective, which they posted a day or 2 days ago. I just wanted to give you my point of view, so we're gonna read through the whole thing, and I'm gonna provide a bit of a perspective. I am an IT architect myself, and I have been doing this for quite some time now. I will be making some assumptions left and right because I am of course not familiar with what they're actually running in the backend, but most of it is rather conceptual. So while I will be showing you pictures of AWS as their sort of gaming infrastructure, I don't know if they're using AWS, but even if they're not and they're using Azure or something, it doesn't really matter because conceptually all these things are the same. So with that said, let's just dive in. Hello travelers, today's blog is a little different from our usual fare. As most of you know, Last Epoch launched on February 21st and the reception has been amazing. In the first week after launch, over 1.4 million of you logged in to play Last Epoch. At our peak, we had just under 265,000 players, all roaming Eterra simultaneously. That's good enough for the 39th highest all-time concurrent player count recorded on Steam, and we're humbled by your support and enthusiasm for the game. There's plenty of cause for celebration, but let's not ignore the obvious. Last Epoch's launch was pretty rough for the majority of you who played online. Your patience and positivity have been amazing, but it obviously was not the launch experience that you or we had hoped for. Now that the initial launch woes are behind us, it's time to reflect on the experience, what happened. We put a strong emphasis on testing our servers and infrastructure ahead of time, so what did we get wrong? Last Epoch's backend team is here to give you a bit of a recap of what went on during the launch. And I just want to say that I think this is an absolute W for Last Epoch that they're doing this. It's interesting to read. It's very transparent, even though they're not even getting all that technical, to be honest, in this post. But still, it's quite interesting what's going on. And yeah, overall, just cool that they do something like this. So the next paragraph or section talks about how the game works. And here we will be swapping also to some architecture overview. Let's begin with a quick explanation of how our game works when played online. When you boot up Last Epoch and enter the game, what you see as a player is relatively straightforward. First you log in, then you select your character, and then you join a game server. Behind the scenes though, what you've just done is communicate with and move through half a dozen online services. These services log you in, provide you with game data, and give you a server to connect to so you can play the game. You connect to this game server, but then the server itself goes out and talks to even more services that authenticate you, load your character data, and check things like your party membership. These supporting services are the backend of our game, and without them our game doesn't work. Some services are more important than others, but as a general rule, most services are required for the game to function. The good news is that these services are all pretty resilient. Behind the scenes, each service is not one program, but many copies of the same program. If one of the copies breaks down, the other copies keep working. Crucially, if a service is overloaded, we can fix that by just deploying more copies of the program. If our services are designed properly, we can handle any number of players. All we need to do is throw more copies at the problem. And this design applies to our game servers too. Last Epoch has never run out of game servers for players because they're all interchangeable, and we can create as many new ones as we need. The closest we've ever come to running out of servers is when we get a spike in players and need to wait a short amount of time for extra ones to boot up. This last sentence, particularly when they say extra ones to boot up, this is something that makes me feel that this is an automated system, right? You're not manually going to add and remove servers all the time. You are going to automate that based on players' requests, based on the load in the systems. You spin up or spin down more copies of existing services. I thought, okay, let's have a little bit of a look here at the architecture. So this is a container-based game backend architecture. Container-based just means that the services and servers are running in containers or pods, as you sometimes also call them. That is what you see over here. So we're gonna have a little bit of a look what is happening. So we're over here, right? We're the players. The Amazon CloudFront, this is your content delivery network. You get your game content and downloads from that. So here it says game content and downloads. This is basically where you download Steam, if you will. And then you install Steam. And if you run Last Epoch from Steam, you have a client over here. And so the client is basically on your PC, right? It's local to your system. And the client starts to communicate with the AWS backend. Backend is a bit of an ambiguous term here because the backend is either this whole thing, but that's not what the devs mean when they talk about backend, because what they see as the backend is here, is the backend workflows, right? But typically from an architecture perspective, like this is the client, these are the servers. You could also consider this a backend. So backend is a little bit of an ambiguous term in IT architecture. It really depends on the perspective, what you think is the backend. So you go in, you get through these two components. This is more important for things like routing the internet traffic and whatnot. And then you get into the system. This is a protected environment. You have a firewall over here. You have a net gateway, an application load balancer, and availability zones. Maybe to drill down this availability zone a little bit more, you have your public subnet. This is the area that is publicly exposed. You can get here via the internet. This is why you have your security over here, right? You have your net gateway, so that is the security layer. And you have an application load balancer because you get the traffic and you need all this incoming traffic. It needs to be a load balance, which basically means that this component makes sure that not all the traffic is ending up on like one game server and the other 400 game servers are not used, but this balances the incoming load or the incoming traffic over the available underlying services. That's what this component is supposed to do if you configure it properly, right? So I want to stress that if you don't set this up properly, this picture is simply not going to work. And it's very important to realize, I think. So you run everything on multiple availability zones, and if then you have an issue that is related to the availability zone, you can swap over to a new one without too much impact. And on the other hand, you have also horizontal scaling, and here's an auto scaling group. These are the servers that spin up and spin down, what they're talking about. So you have generic services here, right? Account services, social services like chat, let's say, other services, game services like the game servers. And these are all independent services. They're all copies of each other. So every game server in the post is the same, and you can create as many as you want. And if you would use an auto scaling group like this, Amazon is managing that for you. They will automatically spin up and turn off services and servers. So you see that by doing like vertical splicing and also horizontal scaling, you are by default and sort of by its very nature of how this is designed, you have a very resilient architecture. This is one of the main advantages of using cloud architecture and a cloud infrastructure. So these backend workflows are important because this is basically where a lot of your logic lies. And what you have to do in some of these backend workflows is basically design and configure how these underlying things work and how you're going to connect, for example, to all of these services. So this is of course a conceptual overview. If you would drill down even more and go into the actual applications being used, then you'd run through even more servers. But I think this does give you a bit of an idea of the complexity that goes on behind the scenes, because you're only here. But before you actually get to a game server and can start playing the game, you have a lot of other things going on. So they talk about authentication, they talk about basically anything else that needs to happen. So with this knowledge, let's get back to the post and keep on reading. So then we go to the preparing for launch part. And they say the designing our services properly bit is the hard part. And hopefully by me just showing you roughly the conceptual architecture, you can start to see a bit of why. For some of our services, it's very challenging to design them in a way that actually lets us scale just by throwing more copies at the problem. If you were around for the launch of patch 0.9.0, our first multiplayer release, you saw our game go down as soon as we crossed 40,000 players. Why? The service that matches players to servers had a design flaw where it started slowing down when there were many servers available. Once about 40,000 players joined servers, the performance of the matcher or the matchmaking service got so bad that it didn't matter how many copies we threw at the problem, every copy would crash under the strain. The backend team spent much of the time between 0.9 and 1.0 hunting down and fixing these sorts of design flaws. Some flaws could be easily fixed, others require entirely new services to handle our players' data in a way that could actually scale. We were given a blank check to do whatever was needed to support our launch, so the only obstacle was time. By the week before launch, we seemed to be in a reasonably comfortable spot. Everything was built and we'd performed multiple rounds of load testing on our entire backend to ensure it could handle the volume of requests we expected at launch. The results were promising and we hadn't pulled any punches on the testing either. We were as ready as we were ever going to be for launch. And I think this is all also like a true statement. At some point, you have basically exhausted all your options. I know this from my own experience as well. It's like, yeah, we can't avoid that we're not gonna get into any issues, but you can only do so much when preparing for a launch like this. I think that's a perfectly fair way of putting it, and also very true in my own experience. Now, we could go back one more time to the picture at this point, but I think this makes quite a bit of sense. Maybe that whole service thing that matches people to servers, that would happen over here. So you have a matchmaking service, which is, you know, another service or a game service. And underneath that you have servers, right? Actual instances where you play on. If your service has an issue, and especially a matchmaking issue, it doesn't matter how many game servers you spin up, because the issue isn't the number of servers that you have. The issue is that the game matchmaking service isn't capable of connecting you in a timely fashion with an underlying server so you can actually load into a new zone. So the morning of launch. For something like a game launch, readiness is mostly about having a plan. This is true for any launch, I would say. It's also true for a game launch, but whenever we launch something, then we have the same thing. You can have confidence that you've tested and prepared. You can have confidence that you know how your services work. Yeah, that's actually quite important that you know how your services work. But you can't have confidence that nothing will go wrong. True. Instead, you plan for what to do if something unanticipated happens. So what you typically do, at least from my experience, is you make a run book. And you also make a run book for when things go wrong. Who to call. You set up like alignment sessions up front. You take what we call aftercare. And aftercare means that if your product goes live or into production, or in this case into launch, that you have the people sitting there available basically 24/7 for 1 or 2 weeks. On the morning of launch day, we went to scale up our server matching service to the numbers we used in our tests. And to our great surprise, it refused to spin up more than half the copies we asked for. Once again, also this spin up thing makes me believe that they're using the container-based architecture, because that is typically what you say about these pods and about these containers, like you're spinning them up. Server matching is a critical service. And in our testing, it needed a high number of copies to handle all the players we expected, so getting stuck at half capacity was a serious problem, which makes sense. You might ask yourself, like, why are they only spinning up all these servers on launch day and not, you know, a week in advance or something? You have to understand that this costs money. If you, a week in advance, would spin up enough servers to be able to handle 200,000 people, you would waste so much money in that week's time, because it costs a fortune to do this. So this is why they only do it on the morning of launch day. I think that's reasonable. This wasn't even the only pre-launch hiccup. In case of unfortunate timing, our service host, so that could be AWS, right, had an incident the night before, still ongoing at launch time, that affected us in a way that prevented us from deploying changes to any of our backend services using the tools we had relied on for months. Our ability to fix our services was killed at the same time one of our services needed fixing. What you can imagine over here probably is that this is sort of a package deal, right? Like you get into these AWS clouds, you have a portal, for example, where you can log in and you can see all sorts of things about these services, monitoring, but also of course configuration tools. And this is all provided by, in this case, Amazon. If any of those things aren't working, then you have a serious issue. We had workarounds for these problems, but they were not quick fixes. We were going to need to break apart our deployment tools and move our services around manually, but this was not something we could sneak in before the doors opened to all our players. Minutes before launch, we estimated that we could handle maybe 120,000 to 150,000 players before things started to fail, and we crossed our fingers we'd be able to resolve our issues before the player count crept too high. Well, you know how that went. Yeah, we know how that went. It didn't go great. The issue with not having your regular tooling is that these tools typically don't only make it easier to make changes, these tools also typically include a lot of automation in what you call typically a deployment pipeline. And in that pipeline, what happens is a lot of automated testing, all the way up to automated deployment, and it's also fairly quick. If that pipeline tool is unavailable, you can still do all of these things manually, but it takes much more time, like much more time. And it's also not recommended because any manual deployment carries a high risk of human errors and human mistakes. Then the next 5 days. What unfolded over the next 5 days was a blur of emergency fixes and risk management. As it so happened, our first 2 pre-launch problems were only the tip of the iceberg. In software, you sometimes run into a problem called cascading failure. When different parts of a software system rely on each other, an error in one part can cause errors in all other parts as well. This can make it look like the entire system is failing even though only one part actually is. Finding the root cause of the failure is very difficult when everything is failing all at once. The server matcher problem had caused a cascading failure in our systems. When players failed to connect to a server, they usually just try again, meaning our struggling server matcher had to deal with 2 to 5 times the number of requests it would normally need to deal with. In many cases, players would get through the first half of server matching but would fail the second half, meaning servers would bring themselves online and then shut down again because a player never connected. Servers booting up and shutting down put pressure on our other services, and so some of those also started to fail. They don't really explain like why that is, but I can guess why this typically happens. So, and I don't know like what caused the issue, but why this is such a problem. And so this server matcher is a little bit like the load balancer over here, if you will. This server matcher has to connect you to an underlying server. So it is this layer on top of all the, well, maybe not all, but a significant number of game servers. It picks one for you, connects you to it. And what you have to realize when you say this about this matchmaker is that this matchmaker doesn't sort of magically know where all of these other underlying services are. You have to tell them, and they will spin up themselves, usually looking at some sort of internal config file or something that tells them where to go, and then they set up those connections, and they may probably authenticate and authorize themselves against other servers. All of this takes some time, all of this takes some network and some traffic. So if you constantly have this matchmaker that spins up and then goes down and spins up and goes down and spins up and goes down, you are also constantly doing all these connection requests to the other services that you need. The one that does your data and the one that does your authentication and whatnot, which puts this sort of strain on the rest of the infrastructure. So by getting an issue in one part, because that is now constantly doing connection requests and I don't know what other sorts of interactions with other services, they become overloaded too. And I can even imagine that they do a request and then they go down, and then the other service wants to respond with your player data, for example, and now all of a sudden the service is gone, so it doesn't know what to respond to anymore. I can completely see how within no time you've created a mess that it would be hard to foresee probably, just because one component is constantly shutting itself down and spinning up again, asking everyone around them like, hey, here I am again, oh, I'm down, and then you have to break all the connections, oh, I'm up again, establish all the connections, oh, I'm down. You can hopefully see why that could be a problem, and then you do this for each player 200,000 times. That will become problematic real fast. So when we fixed the server matcher, some other services continued to fail because they had trouble recovering from the chaos. Our deployment tools still required attention, so fixing these other services was a slow and manual process. To clear up the backlog, we needed to scale some of our services way past what would have been needed had the game been working smoothly. This brought with it new challenges, since cloud services have some built-in soft caps that we would never have hit under normal circumstances, and working around those caps took time and in some cases code changes. We identified and cleared away many of these caps before launch, but we hit new ones as we scrambled to rearrange our backend. Again, with the knowledge so far provided, I think this makes a lot of sense. You can see why this is a problem, and you can ask like, hey, but why are there soft caps, for example, on these cloud services? Isn't the whole idea that they sort of scale infinitely? These are mostly there for your own protection if you are making use of these cloud services, that someone else, should you get hacked or something, or just have a developer that doesn't know what they're doing, then and I don't mean developer like last Epoch, I mean an individual, right, like a coder. If you have one of those that just doesn't really know what they're doing, with no soft caps, they could cause some real issues in like spinning up I don't know how many services and servers and costing you a huge amount of money. So typically you have this and it's mostly a good thing, but in this case it's problematic and you can't easily remove them because that would defeat the purpose of it being there in the first place. So I can see what's going on. You may be wondering, if the problem was recovering from too many players, why did we not simply have some downtime or at least turn on player queues to alleviate the pressure? The answer is that we did, but the problems ran deeper than the server matcher. At various points during the launch we brought down our services and many of you found yourselves in long queues and we struggled to keep up. Inevitably, once we started letting you back in, we would run into problems again, and we could not clearly see what those problems were until we scaled everything up so high that the services stayed online and operational even though they were strained from other failures in other areas. Sprinkled in with our deployment woes, we had a couple of genuine code problems in our services. One of the few examples where we straight up overestimated our ability to scale, was a bottleneck in how quickly we could process requests for a single town in a single region of the world. In last Epoch, once you reach the end of Time Town, you will always load into that town when you enter the game from character select. We knew ahead of time that this bottleneck existed, but we underestimated what would happen when we suddenly fixed a broken game and hundreds of thousands of players all tried to access the same town at the same time in the same part of the world. We thought that the server matcher would be a little slow at first and then it would start to fix itself as more and more people got into the game. What happened instead was that it took so long to get into the game that almost no one actually succeeded, so they quit and tried again over and over, and the problem never tapered off. This was not the kind of problem we could fix by just adding more copies of the service, so it took some emergency problem solving. Each time we found a problem and fixed it, we immediately saw improvement, but this allowed even more players to enter the game and play, which would uncover the next problem and so on. You can see that happen as well. I think that doesn't really require any more explanation. Then the final fix. By Sunday we had managed to fix, deploy and scale our services to the point that most of our backend was handling over 200,000 players just fine, even through flurries of retries and errors. Yet amidst all the chaos, there was still some strange behavior happening on the game servers that was causing problems. During our periods of stability when the game was up, Players were able to connect to game servers, but their connections would often time out once they got there. Every time a player joins a game server, the game server checks to see if the player is in a party. This is a simple operation, and in all of our testing we saw that this check completed very quickly, even under heavy load. Yet our logs were telling us that checks for a player's party were taking up to a minute, sometimes even longer. Over the first 4 days, we made a number of changes to the party services to alleviate pressure. Each fix helped for a while, but inevitably it always slowed down again until players could no longer join servers. On day 5, with all the other backend problems solved, we were able to get a more precise look at the party errors, and the culprit was a single innocent looking line of code. A single line of code that was supposed to be the most efficient request in our entire party service, but instead ended up consuming all of the service's resources under heavy load, slowing the entire service to a crawl. It took about an hour on Sunday afternoon to rearrange the party data so we could check over 200,000 players' party memberships without bringing down the service. We deployed the fix, the game came back up, and it's been online ever since. So we're getting to the end here. This blog post is 2,000 words long, and there's still a whole lot more we could say. Internally, we've been cataloging and planning for ways we can improve, and we want to ensure that our processes moving forward include the lessons we have learned from the launch. First, we learned the hard way that our internal tooling for deploying our services was not robust enough on launch day. Our tools were too brittle, breaking when certain services went down, and too inflexible. Too many manual adjustments needed in an emergency. When the system came under strain, we couldn't deploy our fixes quickly, and we usually had to cause additional downtime to it. Had our deployed tooling been stronger, we could have gotten to a stable state much more quickly. Our top priority on the team right now is improving our tooling so we can effectively respond to situations like these. Second, our services themselves could be more flexible. We had to make many changes over the course of the launch that should have been simple configuration changes, but instead required a full redeploy, which turned simple fixes into long, risky operations. This weakness was identified ahead of time and now has become a top priority to improve. They're keeping it pretty generic, but this is a paragraph that means a lot, I think. So what they're basically saying here is that, first of all, they were hampered by their tooling, right? And this has to do with the second point, of course. But even then, it seemed that the design of the services had quite a bit of, well, you could almost say hard-coded config in there. And rather than, for example, using a config file, which allows you to make changes on the fly without doing a full redeploy of an application, and I'll come to why that is so important. And instead, what seems to happen here is that there is no such configuration file, or at least not for the changes that they're talking about over here. And rather it is, well, I suppose hard-coded somewhere. And the only way to get something that is hard-coded changed is if you basically upload a new version of whatever is hard-coded. And that typically then results in a redeploy or a re-upload, or, you know, just creating a new version and uploading that. And that is an issue, first of all, because they didn't really have the tooling in place anymore to do deployments. But also, it's of course incredibly inefficient if for all of these changes, and for some of them I'm sure they weren't even clear if it would do anything, right? Because they are in bug fixing mode, right? They are in sort of chaos mode at this moment, and you want to make changes quickly and see if there's any effect. If you, for your change, have to redeploy your entire service over and over again in order to see if it even works, yeah, that is incredibly inefficient. And they're admitting here basically that that is not great design. Third, we need to do a better job of anticipating how player behavior affects our backend. Our testing was designed to simulate how and when our services would break, but we needed to spend more time considering how the conditions would continue to change once things start failing. Now that we've seen what happened during a fraud launch, how players put pressure on services differently than when everything is working, we'll be able to incorporate that data into future tests. And this is true, of course, but I think this is also the hardest thing to do, because you will never really know how people will react. Like, we see this all the time at our company. Like, we think we know what's going to happen, even from a user perspective, and they always manage to do something that we did not expect at all. So while of course they should incorporate this data into future tests, it is also I think a simple reality that you cannot always predict this, and I think they'll find more things in the future that they didn't predict, which they can then again incorporate into the future tests. But these are just things that I feel you should deal with by having proper monitoring after going live and making sure your deployment tools work and making a flexible architecture that you can change and configure on the fly, rather than spending maybe too much time trying to think how players might behave, because I think the reality is that it's just incredibly hard to predict. And then they do, I think, an interesting note as well. As an aside, our testing effort in general was a huge success. Despite how it may look from our launch struggles, our testing identified many other critical issues leading all the way up to the week before launch, and without those efforts we might still be trying to fix the game to this day. Even though we're post-launch, we plan to continue to incorporate load testing into our regular development cadence looking forward. But do they mean that they're like load testing at an earlier stage when they're not load testing the entire architecture or load testing components? I'm not entirely sure what this means actually. And so it's a little bit hard to assess what they aim to achieve. But clearly a regular load test is always a good idea. But I think it makes the most sense that you load test your entire architecture rather than components, because components might also give you a bit of a false sense of security. And you can argue you could do both, and maybe that's what they want to do. I'm not entirely sure. And then we move on to the last piece, the thank you note. With the launch behind us, we're all very thankful to you players for showing so much passion for the game despite the rocky start. ESG started from a group of gamers hoping to make the ARPG they wanted to play, and now ESG is a group of gamers hoping to make the game you want to play. Our passion, enthusiasm, and when deserved criticism have continued to encourage our teams to deliver that game and push the definition of what an ARPG can be, should be, and will be. Our team could not have made Last Epoch what it is today without you, and we will endeavor to make keeping the game you all deserve. Here's to bright future, travelers. It's a nice ending, I think. Also, the game is these days in a pretty good spot. Again, the reviews that were really bad at launch have mostly vanished. So I think the game is back to almost 80% or so on Steam. And of course it gets a lot of critical acclaim. And rightfully so. It is a great game. So I'm aware this is probably a pretty long video at this point. But hey, I hope it was worth it. Anyway guys, see you in the next one. Tomorrow, the weekly roundup. And we'll talk soon. Bye bye.